1990 to 2000.
They started competing with the copods.
We want students to be able to communicate why things happen in the natural world. And in science, we do that in a formal way. When we say we just explain things, we're not just describing them, we are actually formally making a claim based on evidence that we collect, and we use reasoning to support that claim. That's how scientists make sense of phenomena, and that's what we want students to be doing in classrooms.
So our variable was the elusive fish, and our prediction was if the zebra mussels continue to coexist with the elusive fish population, then the elusive fish population will decline because they both compete for the same resources.
So that the the phytoplankton there won't be enough for both of them to keep them alive.
Throughout those 10 years, they
yeah.
increase in population.
Because like they don't all just come at once.
Yeah.
They gotta add up and add up.
The explanation tool is a writing scaffold that helps students construct scientific explanations about phenomena in the natural world.
It is really challenging for my students to be able to construct an explanation, specifically a scientific explanation, without having this tool.
Using this tool for the first time can be difficult for students, and so we suggest that teachers model how to fill out the tool first so that students learn the process.
And since I'm using my example to help you with yours, I said that zebra mussels eat plankton and rotifers are zooplankton. And I use some of the data that you're going to find.
Students can either
from
collect their own
1992
data
to
or
1996.
they can work with secondary data sets, data that someone else has collected out in the world that they then can bring into the classroom and manipulate and analyze for themselves.
It was really important for them to be on their own. They got the iPads, they went on the website. Instead of me just giving them the data, they could actually go find it, graph it, analyze it, and then discuss it.
The River Ecology Teaching Case Materials helps students investigate the invasive species, the zebra mussel, and its impact on the Hudson River ecosystem through a web tool that lets them actually look at over 20 years worth of data in the Hudson River. They get to see the population of the zebra mussels prior to their arrival and since their arrival, and they can correlate that with the populations of the other organisms in that ecosystem to see if there is change, to see what the impact is.
And which one do you guys have? Dissolved oxygen. Which one you guys want? Haven't figured it out. The zooplankton. The water temperature, I love it.
The first thing students do in the tool is they write their testable question. In this case, students are writing out what is the effect of their independent variable on their dependent variable.
So my question was, what is the long-term effect of zebra mussels on the freshwater mocks?
And it's important we start with this because that's going to frame the entire investigation and all the components that go in the tool. This is the thing that they are explaining.
So now that you have your question, let's talk about the background knowledge.
Once you've defined what your question is, you really need to make sure you understand a little bit of background information about the variables you're investigating. What do we already know about the factors in the question we're looking at? Because before we can do our own investigation on it, we should know what already has been studied.
Both zebra mussels and freshwater moths eat both phytoplankton and zooplankton, so you can write that.
Evidence is the scientific observations and data that we're collecting based on our testable question. It's the data from our independent variable and our dependent variable. What goes in the evidence box on the tool is a summary of that data.
The relevant evidence that led us to our claim is the bar graph shown above, because in the bar graph it shows that even though the number of zebra mussels increased, the amount of dissolved oxygen remained leveled.
So after looking at all of that evidence, we are hopefully able to see some kind of trends or relationships, patterns in the data, and that's when we are able to articulate a statement that answers the question. So the claim is an answer to the testable question from the top of your tool using the evidence to make that claim.
Based on the variables that we spoke about as a team, we realized that there was no relationship in a whole between temperature and the zebra mussels.
After students have summarized their evidence and after students have made a claim, we have them then articulate the relevant science concepts that help make sense of that evidence, that will help support that claim.
Science concepts that we came to were interactions between biotic and abiotic factors.
After they've summarized their evidence, made their claim, and summarized the science concepts that are relevant, they put this together in a statement of reasoning. The reasoning makes connections through the lens of the science concepts from the evidence to the claim.
The claim disagrees with our initial thinking because as the zebra mussel population increases, the amount of dissolved oxygen relatively stays the same.
After you've done these separate components, you put them together in a formal scientific explanation. The scientific explanation is the synthesis of everything you've been working on, where you put all the pieces together.
It takes a little time at the beginning. Once they get it, it's something that they're actually going to do naturally. Nicole?
Our variable is chlorophyll A, which is a phytoplankton, and before the zebra mussels were introduced in 1990, the chlorophyll thrived in the Henry Hudson, approximately 1,300 per 16 microgram liters of chlorophyll.
It's important to have students then share their explanations with other kids, to challenge their ideas, to clarify their ideas, to argue about the phenomena and the mechanisms that are causing that phenomena, to strengthen their own comprehension.
Do you guys think that they used enough of the science contest because they only used one?
It's not. They did amazing. At the beginning, I was like, I don't know how to do this. Oh, Miss, come help me. But I was like, oh, I got this. So I feel like they're really confident now. Something that they're going to use in the future. I hope so.
Well, I'd say that the claim is really good. It answers the question really good. I feel like it could elaborate more on the question, like how.
We want this to be a collaborative process. We're learning together. And so one way to do this is to have students, as a group, put their scientific explanation on chart paper so that they can then review each other's work and learn, again, the components of a scientific explanation.
For your first graph here, you could always put average for December 31st, 1973 to August 14, 1980.
Learning is taking place through both the presentation of one's ideas as well as listening to other groups presenting. As you're listening to another group present, you are making connections to your own understanding.
If we add what you said, like we should do, I think our presentation will be more fluid because like more people will understand it.
It is really important for students to be able to have a conversation, to actually listen to their peers saying, okay, you missed this point here, and to be respectful of each other.
So this tool is great for middle school students, but when students get to high school and higher level science, they're not going to get papers with a bunch of boxes on them. We want to make them independently able to construct scientific explanations. And so the tool helps teach them that process, teach them the components, but over time, especially when they get to high school, they need to learn how to do it without the tool.
Having the explanation tool as a teacher, it was like an awakening to me. So remember, if you need to use your explanation tool, you could go back and reference it so that I could actually go back and reflect on my teaching. Did I guide them properly? Did they actually know how to go from question to scientific reasoning? And they could actually do this. And that was so important to me. And what was the whole purpose of using the explanation tool?
The explanation tool helped us organize our ideas and help us connect the evidence, the data, to a claim or conclusion that we found out from the data.